Hey everybody, this is Anthony Merheb of Group 16 for the ECE 2020 Capstone. I'm here today to show you just a little rundown of our drone for our capstone project. So our group project for this semester before, COVID-19, coronavirus, whatever you want to call it, happened and had us basically be forced to leave school in quarantine, was to get this little drone over here, which we bought off Amazon, to basically follow a user around, take voice commands, basically be like a little personal assistant for the user. And yeah, and the way we were planning on doing that was by unscrewing it from the bottom, taking the pre-existing flight controller and replacing that with one that we were intending to purchase called the Navio 2. So what the Navio 2 is, it's a hat for a Raspberry Pi that operates as its own flight controller using the Raspberry Pi as a base, basically. And what the Navio 2 has on it has a bunch of different sensors, as a GPS, as a barometer, and it's able to take a lot of small measurements that helps your drone fly and take commands from your Raspberry Pi and basically do whatever you want it to do. Unfortunately, like I said, there is quarantine happening now. We did not receive our Navio 2, so I did not go about ripping the actual thing apart yet because there's no reason to, and we have nothing to replace the flight controller with. So this right here is our basic drone. I could do a little test flight just to show, how the drone flies. Everything within the drone were we able to go along with our initial plans would have been exactly the same, that being the body, the propellers, the speed controllers, all of that. That would all still be the same. The only thing that would be changing is the flight controller. So I'll do a little quick test run to show you guys how this drone would operate in the event we actually had a chance to use it. As you guys can see, this is basically just a little normal drone that you'd expect right now. However, as I said before, in the event we actually had a chance to go through and complete our project, the flight controller inside of this drone would have been replaced with the Navio 2. And that would basically let us program the drone so that instead of me controlling the drone as I am manually right now, it would be able to fly around on its own and basically not require any manual input by the user. And for example, if you wanted to take a picture or something, you could just tell the drone, hey, here we go, just give me a second. Hey, look at me. Take a picture, and you'd be set. However, right now, since we don't have that ability, all we could really do is just control this thing manually by hand. And yeah, in the event we could open this up and replace it with the flight controller and work as a team, we could have basically say, hey, follow me, have it start up automatically, follow the user, tell it to record a certain thing, take a picture. But yeah, right now we basically just have this proof of concept. Unfortunately, we couldn't go through with it, but the idea and everything is still there for our project. And yeah, thank you for watching.
Hello, today I'm going to talk to you about how some of our code works inside our drone. What I'm going to show off specifically is the GPS module that essentially enables the drone to collect the coordinates from the GPS built inside of it, and in doing so will allow it to fly towards its destination, which in this case will be the person's phone. So right here what we have is a means for the drone to actually take in the serial number from the GPS so that I can interface with the GPS, and in doing so it'll establish connection. We also have a couple other functions here that I'll go over. There's write to GPS location, and essentially what that does is it just allows us to track the coordinates as they appear. It's almost like a log. It writes writes the coordinates to a file, and we can look at them. Here we have a function that converts all GPS data into degrees that we can use once again in the other methods. Very simple GPS coordinate conversion system that after it is enabled, it will store it into an array. And finally, we have right here a function that allows the GPS to read the data, and after the data has been read, it is written and stored in such a way that we can interface with the mission planner software, and the GPS can follow the user. Here we go. This is once we have the serial number. This is where it reads in the data from the GPS, and then here, from here on out, we have means to convert that data, and this does it in a it does this. It outputs the data every second, and yeah, that's about it. Thank you for watching.
Welcome to our overview of Flight Planner. We were hoping to use this software to create flight plans for our drone based on its GPS location. We could then upload this to our drone as well as communicate with it in real time to quickly collect flight data, set waypoints for travel, and visualize potential flights. The main page in Flight Planner is the flight data window as shown. This tab has a map on the right-hand side. This map data was collected by Google, but various sources can be used. As you can see, I'm zoomed over Livingston campus, as we'll be using this as our starting point. Meanwhile, the flight data modules are located on the left-hand side. The flight data module displays a simulated horizon with altitude, air and ground speed, cardinal directions, and other information such as yaw and pitch. If we had a drone connected, we could also see the connection quality in this window as well. Below this, these values can be seen numerically in the Quick Tab menu. Next to the Quick Tab menu is the Actions tab. With the drone and flight plan in place, we could use this to commit quick actions to the drone, such as fly to a specific waypoint, hover in a location, go to a base station, or simply take on manual control. The next page we'll be looking at is the flight plan window. Here we can set the waypoints and generate a path for the flight plan. I've set the Livingston Green as the home waypoint. Each additional waypoint has a radius that once the drone enters considers the point reached. This is useful for situations such as obstacles or high winds deterring the drone from the direct path. At the moment, our first waypoint has a radius of 30 feet. This waypoint also displays other pertinent information such as latitude, longitude, altitude, gradients of the Earth, distance between points, etc. Each waypoint can also have triggers or actions associated with them once the drone gets in range. Unfortunately, I cannot show you any of this in action, as we require a prototype drone that we were not able to produce due to the ongoing situation with COVID-19. But we hope this view into Mission Planner gives an accurate representation of how we plan to utilize it in our project. Thank you so much.
On behalf of Alec, Anthony, and Ronnie, and myself, I'd like to say thank you for attending our virtual presentation today. Today you heard about the Follow Us drone. You heard about the functionality of the drone, and you got to see a video of how it functioned. You got to see a little bit of our code base pertaining to the GPS, as well as an overview of our flight planner. We hope you enjoyed the presentation, and again, we'd like to give a special thanks to our advisor, Professor Maria Streaky, as well as to Dr. Godrich, and the entire ECE department, especially since during these times there were a lot of adjustments and we have to be creative and we all have to work together. So we'd like to thank them for all of their cooperation and their support and their care, and we hope you enjoyed our presentation today.